All right, guys. I would like to go through an example problem solving for energies and going through the whole process of conservation of energy problems. And we're going to start off with a situation we've done in class before where I have a cart that is compressing a spring and it is initially not moving. And then a few seconds later, it is at the top of a loop and moving. So first things first, we need to decide what forms of energy are present in the first snapshot and the second, and what's in our system. We do that through our LOL diagram. So first things, what's in our system? We're going to do in this problem, spring is in our system, the cart, and a smooth track. The reason I'm going to say it's smooth is that way we can ignore friction. In the first snapshot, I see that a spring is compressed, so I'm going to say US for spring energy. Put that bar all the way to the top. And I see that even though the spring is compressed, the cart is not moving, so I know that there's no kinetic energy and it is on the ground, so it has no height, so no gravitational potential energy. In our second snapshot, the spring is no longer compressed, but the cart is moving, and it has some gravitational potential energy from it having height. Now, the reason I decided to put more kinetic energy than gravitational potential energy, because I know the formula for kinetic energy is 1/2 mv squared, and the formula for UG is mgh. So even though there's height, velocity is squared, so I think that the velocity is going to matter more and there will be more kinetic energy. We could, of course, check those values later, but for now, we're just going to assume this. So let's set up our qualitative energy equation. So I'm going to say US is equal to K plus UG. All I've done is I've set my forms of energy in the initial snapshot and set them equal to the forms of energy in my second snapshot. Now we're going to make our quantitative equation. So this one was qualitative. Now let's make quantitative. So I know the formula for spring energy is 1/2 K delta X squared. I know the formula for kinetic energy is 1/2 mv squared, and I know the formula for gravitational potential energy is mgh. Now we need to solve. I haven't brought any values to the table yet, but let's go ahead and assign some values. Let's say that the top of the loop here, this is going to be 2 meters. Let's say that the spring was compressed by 0.2 meters. Let's say that the spring constant is 30 newtons per meter. And then let's solve for velocities. We have height, we have gravity, we need mass. Let's say that the mass of the cart is 0.5 kilograms, which would be 500 grams. All right, let's do the algebra first and solve for velocity. I want to isolate velocity, so I need to subtract away mgh first from that side of the equation, and then divide away anything multiplied by v squared. So let's subtract first. Okay, we can rewrite our equation. Let's do it over here. 1/2 K delta X squared equals, minus mgh is equal to 1/2 mv squared. Now let's multiply by 2 on both sides to get rid of that 1/2 and divide away m. So divide away mass and multiply by 2. Great. So now we'll rewrite. V squared is equal to K times delta X squared minus 2 mgh divided by mass. Now we still have this squared, so we'll need to square root both sides to get rid of that square. So now we're left with V is equal to the square root of K times delta X squared minus 2 mgh, all divided by m. Now let's plug in our values. Square root of 30 newtons per meter times delta x, which was 0.2 meters squared, minus 2 times 0.5 times 10 for gravity. I'm running out of space here, times 2 for our height, and divide that by 0.5. Give me a minute, I will calculate that. I always like to do all the algebra first and plug in my numbers last, because that way, if I have a graphing calculator, I can plug everything in one line, and I'm way less likely to make mistakes. Or if I do, it's a lot easier to trace them back. So let's put this in. Square root of 30 times 0.2 squared minus 2 times 0.5 times 10 times 2. Divide that by 0.5. I have to plug it in again. Sorry, this is taking so long. 30 times 0.2 squared, I don't know why it's fighting me, minus 2 times 0.5 times 10 times 2. Okay, divided by 0.5. Square root of 37. I got a value, our velocity would be 6.13 meters per second. Great. Hope this has been really helpful. Let's do another problem in the future.